Welcome everybody to today's webinar. We're just waiting for, we've seen the attendees go up. So we'll just wait for people to join, but you're very, very welcome. Just to give some introduction, my name's Steve Moore. I lead the customer success team in Europe here at Welocalize. We're still seeing the attendee numbers go up and up, which is great. I see we're joined today by some of our existing clients as well as some global companies that we don't currently work with. You're all very, very welcome. It's great to see you all today on the webinar. Anyone on the webinar who's also attended one of our global transformation summits in the past knows how much we enjoy and encourage the knowledge sharing, the information exchange, and the networking that happens at these events and as part of this community that we're curating. And we want to ensure that this continues despite the current challenges, and that we continue to provide content that gives global companies some actionable strategies and also the chance to take part and to ask questions. So I see the numbers are going up. So as people are joining, could I ask everyone to answer a quick question? First of all, you should see a poll coming up soon. Had you heard of BERT prior to this webinar? Had you heard of BERT prior to this webinar? If you can please answer yes or no to that question, we'd be very grateful. We'll just give it another 5 seconds or so for everybody to answer. Let's see what the results are of that. So about 50-50. So yes, 46%, and no, 54%. So that's interesting. That's interesting. So moving on then, for anyone that's new to us or anyone who would like some background, Welocalize is a trusted global language services provider. We work with global businesses in a variety of industries to reach, to engage, and to grow international audiences by delivering innovative solutions in a range of services. Now, in our wider family of companies, we have specialist practices in digital marketing, in advanced technology for language automation, legal, and life sciences. And today we're going to hear from Natasha Latisheva and Gurdeep Gola. Natasha is a machine learning engineer in our language automation team, and Gurdeep is a director of our digital marketing practice. And the subject of the webinar today is we're going to look at the use of natural language processing, or NLP, in digital content. And in particular, we're going to focus on BERT, which is a technique for NLP that's been developed by Google. And we're going to focus on how, by understanding BERT, you can increase the overall performance of digital marketing and of SEO campaigns in multiple language markets. So now on with the webinar and the agenda. Natasha is going to look at what exactly is BERT and what role does BERT play in NLP and machine translation. So more of a technical explanation of how NLP works and how it's applied. And then Gurdeep will look at how does NLP and BERT impact digital content performance and how can I measure it? So how do I gain visibility around content when it's created with people in mind? So I'm going to hand over to Natasha to let her begin, but a quick reminder from me, please do keep questions coming throughout the webinar and we'll do our best to answer them all at the very, very end. Please submit questions in the Q&A panel. You should see that at the right-hand side of the panel. And a recording of the webinar will be shared next week with everybody who registered. So thanks again for attending. You're all very, very welcome. And over to you, Natasha.
Thanks, Steve. So today I'll be talking to you about language models and BERT in digital marketing. Right, so here's a bit of an overview of my part of the webinar. So I'm going to start by introducing NLP, natural language processing, and some common language problems that we see when working with NLP. So then I need to introduce what a language model is. So BERT is a language model, so we need to understand what these things are for and how they work. Then I'll talk a bit about how BERT is different from its predecessors and how we go from having a language model to actually using it to do language understanding. So this is exactly what BERT is doing in digital marketing. It's a language model that's used to understand the meaning or the sense of user search queries in the Google search engine. So just starting a bit broad. So we are in the field of natural language processing for this presentation. And NLP deals with solving language-related problems. If you zoom out a bit, we're actually in AI, so we're trying to find solutions to tasks in some form of intelligent fashion. A common approach to AI these days is machine learning, which refers to a class of algorithms that don't need sort of handcrafted rules to solve problems. They learn those rules themselves from seeing lots of examples of training data. Since about 2006, a dominant approach to machine learning has been neural networks. So now we've got a lot of computing power and we can train these networks, particularly deep neural networks, which are neural networks with lots of processing layers, which can be quite powerful. So modern NLP is often best accomplished with deep learning models these days. Earlier NLP work relied more on these handwritten rules by linguistic experts. But these days we can kind of throw neural networks at the problem and it does a decent job.
Natasha, this is Steve again. What does natural language mean? Why don't we just say language processing?
Yeah, yeah, good question. So by natural language, we mean we're dealing with language as it appears naturally, the way that people actually use it when speaking or writing, not anything that's kind of, pre-processed to be nice, not anything that's a constrained language like a programming language, just natural language as it appears.
Thanks.
Thanks. Right, so in case you're not familiar with NLP already, I thought it'd be quite useful to just describe some common NLP problems that come up again and again in various guises. So a common problem is called word tagging. And this is when you have a passage or a sentence, a bit of text, and you want to tag the words in different ways. Commonly, you want to do something that's called NER, or named entity recognition. And that's when we go through the text and we're trying to categorize each word or a sequence of neighboring words as an entity. And by entity, I mean things like people or organizations or locations, but also often you're interested in things like dates and currencies. So in this example, we've got a couple of dates tagged and some organizations and a bit of currency also. Another common tagging problem is parts of speech analysis. So given another bit of text, a dragon is a large serpentine legendary creature, we want to tag each word as with its corresponding parts of speech. So is it a noun, is it a verb, is it an adjective, and so on. Parts of speech analysis is often kind of the first step of a more complex analysis. So people will kind of do this initially in order to have this categorization, and that information can be used later on for more complex reasons down the line. Different type of NLP problem that is also quite popular is text summarization. So the idea here is that you're given an original piece of text, which might be quite long. This is an article from The Guardian recently, and you want to condense the information down into a more manageable form. And often you can actually specify the length reduction that you're looking for. So in this case, I tell the model that I want the original text condensed to 10% of the length, and the model has to condense it down and bring out the most salient points that summarize the information in the original article. A problem that might look a bit different to text summarization, which is actually very similar when we look at the techniques we use, the types of neural networks, is question answering or reading comprehension. So the problem here is the model is given a passage. So here I've got some information on the Matrix film, and the model is given a question about the passage. So who stars in the Matrix? So the model's got to read the passage, understand it, read the question, understand that, and then highlight the answer to the question in the original passage. So more broadly, we would call both of these problems sequence-to-sequence modeling problems. And yeah, like I was saying, we use the same architectures to solve both these things. Actually, we also use the same techniques to solve machine translation. So this is also a sequence-to-sequence problem. Machine translation, people are more familiar with this problem, and this is quite a big deal to us in Welocalize. So the idea behind machine translation is you're trying to map between language pairs. So you might have a sentence in English and you want to map to the corresponding sentence in a different language like French, but keep the meaning of the segments intact. Yeah, if you're building your own machine translation models, you can do modeling with any kind of niche language pairs that you want. You could train a model to translate between Icelandic and Russian, for instance. And actually, machine translation, some people don't realize, is a more general technique. So we can kind of, quote, translate between a piece of text with a lot of grammatical and other errors into the corrected version of that text. So here we've got a segment which kind of, has various mistakes, and we can train a model to sort of translate and do some error correction to even that out. So that brings us to language models. This is another class of techniques within natural language processing. And a language model is a model that understands language structure and meaning. If you've got a smartphone in your pocket, you're probably quite familiar with language models already. So the idea is, as you're typing a message, you'll probably get recommendations about completions for the word you're on, as well as words after, or sometimes actually multiple words after what you've typed, depending on the application. And the way that works is there's a language model running on your phone doing these predictions, probably a neural network based one. If you're using Gmail, or there's a couple of other email providers, they've recently implemented smart email responses and sentence completions in emails. So that's another language model that's running, reading what you've written already, understanding that, and suggesting what should be the appropriate response, or how should I complete the sentence that's partially composed. So just to be a bit more concrete about how language models work, so at the basic level, language models predict missing words. So given this sentence fragment here, the cat sat on the blank, the language model, its task is to read that, understand it, come up with a representation of this and crunch the numbers, and output the most probable word for the missing piece here. Actually, language models will assign a probability to every possible word in the vocabulary, but here I've just shown the word with the highest probability. The newer generation of language models are able to make use of both the left-hand side and the right-hand side context from a missing word. Older ones could only make use of the left-hand side one. This is something BERT does quite well, actually. It's a very natural representation of both left-hand and right-hand side. So in this example, the language model completes, I like to eat ice cream. So language models, modern ones, are quite good, so their predictions are high quality, and the way that they're able to achieve that quality is they're trained on massive quantities of text. So BERT, for instance, is trained on all of Wikipedia and all of Project Gutenberg, which is kind of a composition of many, many works of literature. So these language models have seen billions and billions of words of text, and hence they know a lot about language and a lot about relationships between words. So they do missing word prediction fairly well. So you might be wondering, what does missing word prediction have to do with understanding Google search queries? And yeah, it's a really interesting connection. So the idea is that in order to do this task well, this missing word prediction, language models have to understand quite a lot about the world, and that knowledge is reusable. So even though we're not interested in missing word prediction and understanding Google queries, we can reuse some of the internal number crunching, the internal representation of text in these models, in order to understand what users intend when they search for various things. So in other words, we would say that these language models learn good representations of text, and this knowledge is reusable. So just to go into that in a bit more detail. So if we go back to our previous example of the cat sat on the blank, where we predicted sofa, essentially neural networks are these kind of layered structures that compute things layer by layer. So when the language model first reads this bit of text, the cat sat on the, that text is represented by a certain list of numbers. And as it goes deeper and deeper into the neural network, those numbers are updated. And these lists of numbers is what I mean by representations of the meaning of text. So the neural network is trained to ensure that these representations are good, essentially. And what I can do is I can feed in sentences into the language model and just extract these internal states and kind of ignore any prediction it would make for the missing words. So I can use the language model in a way that it kind of, isn't intended to be used. But I'm just interested in these representations, so I can just dig them out. So we've got our original sentence, the cat jumped on the sofa. What happens when I feed that into the language model? Well, I get these internal state, this internal state list of numbers out. And what I can do is treat that as a list of coordinates. So I can produce a mapping between a sentence, two coordinates in a space of possible meaning. Here I'm just showing 2 dimensions. This is more than 2 numbers, but just for simplicity's sake, I'm mapping each string, each sentence to coordinates within this space of possible meaning. And when I have a slightly different sentence, like the cat jumped on the bed instead of on the sofa, well, if I feed that into the language model, that's going to be processed in a very similar way to the previous sentence, and the numbers are going to be quite similar. And when I convert these to coordinates, that sentence is going to live in a very similar location within this meaning space. So now I've got the dog jumped on the bed, same exact thing. I feed it through the language model. I don't care about any next word prediction. I just want these states. And then I plot that here, and it's quite close again. So what happens when a user Googles best hairdresser in London? Same exact principle. The language model is going to read the text, interpret that in some way, and generate these internal states. When I then plot that point in this meaning space, it's quite different to the sentences before, but it's in a different area of the meaning space. The thing that using this kind of approach does, so the thing that's nice about using this approach is if a user is expressing the same kind of meaning using slightly different words, for instance, best hairdresser in London versus best place hair done London, or hairdresser in London, or maybe some more complete language, like what is the highest rated place to get hair done in London, we would hope that the language model processes all of these pieces of text in a similar way. We hope that the model recognizes that these are similar queries. And when we go to plot these strings as coordinates, we would hope that that BERT or another language model recognizes that these are actually quite similar. So, so just to summarize all that, so if a user is searching for the best hairdresser in London, we would use BERT or a different language model in order to compute the meaning of that query by looking at these internal states within the model. So how is that actually used to affect sort of rankings of search results? We don't actually know exactly. That's a bit of a trade secret, but presumably Google are calculating the similarity between the query meaning and the meaning of different pages in search results. So this sort of similarity will be a factor in how results are returned, but we don't know to what extent. We just know that it's a new sort of aspect that is now being looked at that wasn't looked at before. So I've given you some background on what NLP is, what language models are. So I hope that this bullet point now makes a bit more sense. What is BERT? Well, BERT is a language model that's based on deep neural networks. So it's been trained to do next word prediction. But how we're using it is we're using it to produce high quality representations of the meaning of pieces of text. So BERT isn't, the first language model. It's not the last language model. But there are some interesting advancements over previous iterations, particularly what I mentioned before. So if we've got this missing word prediction task and we have a lot of left-hand side context and right-hand side context, BERT represents that in a very natural way. Whereas, for instance, if you're familiar with ELNO language models, they didn't do a great job of representing context. We also say that BERT is quite good at handling faraway information. So in the field, we call these long-term dependencies. And that's when, if you imagine you've got a paragraph, that's when the first word might actually affect the final word. So it's these long-term relationships between words. Often words are like quite related to words near to where they are, but often you can get these long-term relationships, and BERT handles those quite well. And then from a technical point of view, BERT has been trained on that huge amount of data on many, many GPUs for a very long time. So they've done a bit of the heavy lifting for you. The reason that BERT is quite popular in academia is because they've made BERT very, very easy to reuse and fine tune. So now if you're an NLP researcher or practitioner doing some sort of language related modeling problem, you don't have to start from scratch anymore. So you can download BERT and you can use that as kind of a base layer for doing language understanding. So you can reuse a lot of the knowledge in BERT and you can fine tune it for any different specific tasks that you've got. Great. So yeah, so a bit of a more technical slide if you're interested in reading more about the topic. There's a really nice review of over 40 studies that have analyzed what BERT actually understands about language. And I put a link to the paper there. So BERT is obviously quite good at understanding language, but it does fall over in various situations in kind of funny ways sometimes. So here's one thing that it does well. So you can use BERT to assign probabilities to any sentence fragment. So BERT can calculate how likely this sentence is, or this fragment is, to tip a chef. And BERT will assign a higher probability to this, to tip a chef, than to tip a robin. So it knows that the first makes more sense. And it knows that those first two segments are worse than to tip a waiter. So it's learned this association between tipping and waiters. But one thing that some of these studies have found is that a lot of BERT's knowledge is kind of based on stereotyping. So if I ask it to complete this sentence, Federico was born in blank, it's going to assign high probabilities to places in Italy. So for instance, Florence. And yeah, I mean, that's obviously like an association that it's learned that's a bit stereotypical, right? Like maybe Federico wasn't born in Florence. Another thing is that BERT sometimes has trouble reasoning, like its logic isn't super solid. So people have shown that BERT knows that people can walk into houses and that houses are large objects, but it cannot actually infer that houses are bigger than people. So yeah, it's definitely some weaknesses, but still a really impressive model all around. Okay, so that's kind of my section. That's all I wanted to say. I'm just going to summarize that. So I introduced you guys to natural language processing, or NLP, and I said that NLP is about applying machine learning, often neural networks, to language-related problems. Language models are one kind of subset of tools in NLP, and language models let you predict missing words. But maybe more interestingly than that, you can reuse the language understanding that language models have for other purposes. BERT is a particularly good language model that understands context very well. And for that reason, BERT is used to understand the sense or the meaning of user Google search queries. Yeah, so that's me.
Natasha, thanks very much. Thanks very much. And thank you to everybody who submitted a question so far. I see a lot of questions coming in, so that's great. Again, the control panel for the questions is on the right-hand side. So please submit those questions, keep them coming, and we'll cover as many as we can at the very, very end. But now over to Gurdeep.
Thank you very much, Steve. And first and foremost, thank everyone for joining us today. As Steve mentioned, my name's Gurdeep. I work across the digital services arm of Welocalize, and my background is in kind of search marketing. So the objective of my section today is to really give everyone context on how Google BERT is impacting the search landscape specifically, and how it may really help inform how we think about optimizing and producing content in a post-BERT world. So I think the first thing I really want to give some people context on is the kind of size and scale of BERT. So according to Google themselves, BERT is one of the largest algorithmic changes in the last 5 years, but actually in the history of search. And in terms of timings, in October 2019, BERT, the language model, rolled out to all English search queries. And by December 2019, they rolled it out across over 70 plus languages.
So Gurdeep, this is Steve again. If it's brand new for non-English languages, so only rolled out a few months ago, what might that mean for a company who invests in localizing their website?
So I think there are going to be some actionable things we're going to touch on in terms of how you can really factor in making your content as accessible as possible. But ultimately, that would be the overarching goal moving forward. In terms of how Google have described it themselves, John Mueller, one of the web trends analysts, really kind of summarized the impact on search really, really well. And he kind of mentioned it's the difference between matching words and actually understanding words from a search engine perspective. And I think lots of what Natasha has spoken to today hopefully answers and gives a lot of context in terms of how Google are doing that. But let's talk about some real life examples in terms of search results. And I think in terms of a pre-BERT world, these queries look very similar, but have very different intent. And in a pre-BERT world, the Google search algorithm would likely recognize and group these queries together and really give a mixed bag in terms of search, in terms of results. And I think since BERT has rolled out, it's really able to understand the entire query and each word simultaneously. So the model, in essence, is able to recognize all the words and each word and how they interact with each other to really determine the true intent across the whole query, and subsequently, therefore, provide more relevant results, which is Google's ultimate mission statement. Interestingly enough, the official guidance, and this is Dali Sullivan, Google's search liaison representative, they came out very quickly and they said, look, you shouldn't think about optimizing specifically for BERT. And again, it's part of their kind of mission statement of rewarding great content. However, there are things that everyone can do and think about in terms of making their content more accessible in this kind of post-BERT world. And what we're going to touch on in the next few slides are really some kind of actionable things everyone can think about in terms of their content planning and also potentially their kind of content production moving forward. So one of the key things is really to understand intent and understand the exact intent of your audience. In this example where the keyword is kind of home weight loss, the audience might be looking for routines, they might be looking for tips, stories, or even equipment. And the more specific you are around the purpose of your content, the easier it will be for Google to ultimately show it to the right audience. I think depending on how the query is also phrased, the same keyword could lead to lots of different types of results. And in this case, these are kind of featured snippet results. And I think once you understand the kind of theme and keyword you really want to target and be visible for, it's about observing kind of what results Google is likely to employ and use that to really define how you structure your content and how you cater for these formats. So whether it is a kind of list article, whether it is a step-by-step breakdown, video result, or even a kind of more long-form piece, really kind of shape your content around that specific intent of your target audience. And ultimately, if it's not easy for a human to find what they're looking for, it certainly won't be for Google or a NLP language model. One of the other kind of key points is in the world post NLP, absolutely kind of simplicity is favored and rewarded. And I think if you can kind of present information in the most concise way possible, absolutely it's going to be more accessible to language models and ultimately potentially help it be more visible in kind of search results. So I think the more you can kind of ask yourself, is the query you're targeting clear from the content itself? Are you answering users' queries directly? And is all the content focused and relevant? And the quicker and easier it is for your audience to answer their query, the more valuable your content is to Google. Another key concept around making your content more accessible is about improving salience and really giving search engines and kind of language parsers the contextual relevance as to what you're trying to guide users towards. So in the statement, fiber is crucial, a user could be looking for information around their kind of internet connection. However, they really could be looking for information around kind of health tips and digestion. And I think having that contextual relevance by kind of supporting content and really indicating that kind of contextual relevance and the semantic relevance from the topics you're producing is really going to help kind of Google understand the main topics of an article and therefore kind of serve it to the right audience. So just to kind of highlight some of the kind of key things everyone can think about. So one is to really understand and define intent. I think being as clear and direct as possible in terms of how you produce and present that information. Really thinking about what supporting content you can produce, but also in terms of the content you produce itself, how can you really include relevant semantic entities and topics to really give that contextual relevance. And lastly is you can test it. So Google have launched a NLP API, and it then kind of, you can use it to ultimately score your content across these different buckets. And I think for companies like us and Welocalize, we are really trying to explore kind of language analysis and take it to that next step. And we're going to touch on the next few slides in terms of how we are thinking about the future. And I think that the first thing is to really understand your kind of linguistic features across the content types or languages you're interested in. And what is quite exciting is our ability to work with people like Natasha and the wider team to really drill down and answer really kind of pertinent questions in terms of what's the optimal structure for a given content type, but also how do I adapt language across markets and marketing activities, and using kind of data and leveraging data insights to really kind of inform that. And how does kind of machine learning really support this scalable analysis and a deeper understanding of how your kind of linguistics stack up? So the first thing we have been testing is kind of extracting content at scale. And again, this could be across a different content type. So it could be a web page, a product description, a PPC ad, or even a social media post. Then running kind of feature analysis to understand what good looks like for a given content type. And then kind of really using machine learning to compute and score this analysis at scale. So again, this can be broadened out to looking at your competitors' content and really kind of comparing what you are producing and how that stacks up across the competitive landscape. And some of those different language features we can really analyze in detail. So kind of language quality, but above and beyond grammar and grammatical issues. So really kind of looking at the kind of writing itself. Complexity, how accessible is your content to the users you're targeting? We can also look at things like sentiment. So is it positive, negative? What is the kind of opinion of a given piece of content? But then also, how does that relate to your kind of brand tone of voice and your brand messaging?
Gadeep, this is a question from me again. This is Steve. What about territories and therefore, I guess, languages where Google is not the dominant search engine?
Yeah, and that's a great point, Steve. And I think I am gonna hopefully cover that in a slide later. But ultimately, where Google are really kind of leading the charge, we know others are going to follow. So I think absolutely this kind of advancement and to Natasha's points earlier, kind of but the advancement of that model is going to be repurposed by other platforms' tools to really help shape the way languages understood moving forward. So irrespective of the platform tool, I think NLP is going to be very relevant in a future state. And just talking a bit beyond language analysis, and again, what is really exciting is being able to start bridging the gap between language performance and language quality and all of those language features, but also digital performance and how are these assets and content types performing. And I think what we see as real opportunity and the real kind of future direction of where this kind of convergence is happening is really overlaying views of linguistic quality with performance analysis. And I think if we're able to really do that at scale across different content types, across different languages and markets, we're going to be in a position where we can really not only understand what good looks like, but really isolate underperformance as well. And it's going to give us lots of new avenues to test and new opportunities to optimize and improve. And just quickly talking to the future, and to your earlier point, Steve, I think what we have already seen is, irrespective of the platform tool, the language, I think ultimately Microsoft have already confirmed they're kind of repurposing parts of BERT for things like data annotation. But we know that ultimately it's going to help their understanding of what users are looking for, and therefore kind of how to serve kind of content in a future state. And that brings me to a close. So I'd like to thank everyone and hopefully can answer some questions.
Thanks, Gadeep, and thanks, Natasha. Thanks for the whistle-stop tour of BERT and explaining how we can increase the overall performance of digital marketing in multiple language markets. Just finally, a quick question, another poll question for all the attendees on today's webinar. There should be a question coming up very, very soon on the screen.
Steve, I apologize. There's a technical issue with the second poll. I apologize.
No problem, no problem. Well, we'll skip that bit and we might follow up. But just in summary, we hope you found these two talks useful. I mean, there's been many questions, so lots of people have been inspired to ask a lot of questions and to ask so what and to ask why. All our contact details are there on the screen if you'd like to continue the conversation. We do have some time to handle some of those questions, so please share anything that we haven't yet answered. There's a handout as well that we prepared for you all. So if you can access on the right-hand side, you'll see a handout section of the control panel. That's free for everybody to download. And finally, please do stay tuned for future webinars. We do want to maintain the knowledge sharing, the information exchange that we feel is so important in our industry. And we've given a couple of suggestions here about what you might want to do next, whether it's book a free discovery workshop to find out if NLP and BERT can help your business, or to talk to us in more general terms about how digital transcreation can boost your marketing, your localization campaigns. You can get in contact with all of us there or send an email to info@welocalize.com. So I think, Natasha and Gadeep, we do have time to look at some of the questions that have come in. So I'll start with those questions. Most of the examples you've given are consumer or lifestyle focused. How does this apply in the B2B market where people might not ask questions?
Yeah, I can take that one. And Natasha, feel free to jump in. It's a great question. And I think generally the principles of kind of what we've spoken about are not going to change whether they are kind of B2C or B2B. Obviously, the user journeys are going to be very different. But I think in terms of the principles of how to really surface your content and make it more accessible to kind of ultimately language models, I think that is only going to help your visibility and your performance of your B2B content.
Okay, thanks. Just going on to the next question now. How do I prioritize which content to optimize or create with BERT in mind?
Yeah, so that is a great question. And I think some of the kind of linguistic views that I kind of speedily walked you through, I think we are doing a lot of work in that space to really understand at a language level, even at a kind of product level, at a given language, what good looks like and where there's room for improvement. So I think ultimately what it can do is give you real opportunities to optimize existing content. But then to kind of some of the stuff Natasha talked to earlier, it can really help in terms of identifying gaps and understanding and then correlating your digital performance to those gaps. So I think very similar to a kind of content gap analysis where you're going to have ultimately opportunities to improve existing, but also to produce net new stuff. I think we could really apply some of those principles of BERT to really take that understanding to the next level.
Great, thanks. Moving on to the next question. This all feels like a huge technical advancement. What do you think will come next? Maybe Natasha, if you could take that one.
Yeah, sure. So, I mean, like I was saying, BERT is a very good language model, but there have been sort of models before, and I think there's going to be more research into improving the quality of these models, probably particularly in the generative direction. So things like chatbots, I think, are going to start improving as they start to understand better what users are actually talking about. At the moment, if you've had the misfortune of interacting with chatbots, you'll realize that they quickly go off the rails very quickly. So yeah, I think that will definitely improve. NLP, just as a broad field, is probably one of the most active areas of machine learning at the moment. So actually, I think it's a really exciting time to be working with NLP and kind of getting your hands into it.
Okay, great. And this might be directed at you as well, Natasha, or either Natasha or Gadeep. What are your most cutting edge clients doing with this technology?
Sure. Yeah. So we've got a variety of NLP projects that we work on for different clients. It completely depends on the client and the sector. I mean, a lot of our work is in machine translation, so we're always trying to improve our MT models. We also do a lot of work in kind of automated understanding of the meaning of text. So, for instance, if you've got a lot of text and you're trying to find like the natural clusters of meaning or like grouping sentences together. Other people are more interested in sentiment analysis or tracking how people feel about a certain product or a certain company on social media, maybe over time. And then, yeah, like I was saying, generative models are still kind of in their baby stages at the moment, so they make a lot of mistakes, but we're looking into some of those actually, so like generating variants of sentences for machine translation. So there's a lot of interesting NLP work going on.
There's a $64,000 question for anyone that wants to take it. Do you think NLP and machine translation could in the future almost or entirely replace human linguists?
Yeah, so I'm not sure, but I think it's improved a lot in not that many years. So I wouldn't be surprised if more and more of like the work goes to these machine translation models. I think for sort of high risk scenarios where you need the translations to be flawless, for instance, in like marketing product pages, that will pretty much always be reviewed by a human, right? Because the consequences of getting it wrong are really, really large. But yeah, I wouldn't be surprised if MT continues to expand and the linguist role shifts increasingly towards post-editing machine translation output, which is what we've seen over the last some years.
Okay, great. We've probably got time for just one more. How does the BERT language model handle words that are the same spelling but have different meanings, such as well meaning good, thorough, a well for water, in good health, etc.?
Yep, no, that's a really good question. So BERT's representations of a word are completely contextualized. So if you're familiar with word embeddings from before, so things like word2vec or glove vectors, those were static. So the representation of a word didn't change depending on how it was used. That's really not the case anymore. So if you were to look at how the word well is represented in those three different contexts, it would be completely different sets of numbers, which would map to completely different meanings. So yeah, in the last few years, that's been worked out, and words are contextualized quite well.
Okay, great. Ladies and gentlemen, we're pretty much at time. So thanks so much for sharing those questions. Thanks again to Gadeep and Natasha for answering them. If you have asked a question which wasn't addressed on this webinar, then I promise we will follow up with you in the coming days with a direct answer. But thank you again, everybody, for joining us. We really do appreciate it. And please stay safe, everybody, and we'll see you on the next webinar.